Topics covered in this quiz are related to induction motor. When resistance is added to induction motor rotor, maximum torque increases or remains same. Torque is equal to KSR2 E2 square divided by R2 square plus SX2 square. Torque is maximum when denominator is minimum, that is R2 is equal to SX2. Substituting R2, we get maximum torque is equal to KE2 square divided by 2X2. Thus, maximum torque does not depend on rotor resistance. As rotor resistance is increased, starting torque increases, but maximum torque remains same. However, slip at maximum torque increases with rotor resistance. In a 4-pole induction motor, slip is 5%. What is the motor speed? Synchronous speed is equal to 120 F by P is equal to 1500 RPM. Slip is equal to 5%, that is 0.05 per unit. Speed of rotor is equal to 1500 minus 1500 into 0.05 is equals to 1425 RPM. Is it possible for slip to become zero? Three-phase voltage applied to three-phase winding produces a rotating flux. Let us consider only top and bottom bars of squirrel cage. During running, rotor slips behind the stator flux. When speed of rotor becomes equal to stator flux, current is not induced in the rotor. Hence, torque becomes zero. However, torque is required even at no load to overcome friction and windage loss. Hence, slip can never become zero. Whether start time hot is higher or start time cold is higher. Start time is the time taken by motor to reach limiting temperature in case motor stalls or fails to rotate. When motor stalls, heat is not dissipated and stored in motor. Heat stored is equal to mSDeltaT, where m is mass, S is specific heat, and delta T is permissible temperature rise. Starting current of induction motor is very high. During starting, power loss is due to copper loss. Hence, start time is equal to mSDeltaT divided by I square R loss. Based on this expression, safe start time hot and cold for stator and rotor is obtained. Safe start time hot of stator is equal to mSDeltaT divided by 3I square R1. I is starting current, delta T is equal to limiting temperature minus operating temperature. Limiting temperature is limited by class of insulation, which is 155 degrees centigrade for class F insulation. In case of rotor, I2 is rotor current during starting. Limiting temperature is limited by braze, which is considered as 450 degrees centigrade. In case of start time cold of stator, delta T is equal to 155 degree minus ambient temperature. Ambient temperature considered in India is 50 degrees centigrade and in Europe is 40 degrees centigrade. For calculating start time cold of rotor, delta T is equal to 450 degree minus ambient temperature. Start time of motor is lower between start time of stator and rotor. Start time cold is higher as delta T is higher in this case. Force area of rotor bar is reduced and resistance of rotor bar is increased. Starting torque increases. However, start time of rotor decreases. Low start time may be acceptable for pump motor. However, in case of fan, diameter is high, resulting in higher moment of inertia. Hence, starting time may exceed safe start time. Why there is a dip during starting in induction motor torque? One possible reason is the presence of seventh harmonic. Even if seventh harmonic is not present, still there is a dip in torque. It is due to skin effect. At starting, torque is equal to Ksr2 E2 square divided by Sx2 square. Thus, torque is proportional to 1 by S. As slip approaches 1, rotor resistance increases due to skin effect. Hence, starting torque increases. Torque at speed 0 is called starting torque and dip in torque is called pull-up torque.